Okay, so Algebra 2, we've got this new lesson here on 5.1. You can see as you're looking here, you've got a brand new shape. We're not dealing with lines. We're actually going to be dealing with parabolas. And guys, with parabolas, they show up all the time in a real-world context. You might not think so, but that's honest to goodness the truth. A parabola looks like one of these two shapes that we have right here. You could have something that looks like a U. As you look at these arrows, you can see that the arrows continue to go upwards. This would be known as opening up. This opens up. Look at these arrows going forever upwards. It looks similar to a letter U. Right over here, this one, as the arrows are pointing downward, you could say this opens down. And by the way, that will be one of the questions that you're going to have to address, whether a parabola opens up or opens down. Now, to be sure, in science classes, you're going to hear this. Any object that is thrown will follow the path of a parabola. And you can think about your favorite basketball player as a basketball player is throwing that basketball up towards the hoop. You watch the path of the ball. It's going to follow the path of a parabola. Guys, even when you go to the drinking fountain, look at this. Here's a little drinking fountain. You watch the path of the water. And, of course, it's like the water particles are all streamed together. You get to see the path that one little droplet of water would be traveling in. You could see it travels in a parabola. That's the nature of gravity pulling down on objects. Gravity is going to affect this type of a shape. So we see it a lot in the real world. We see it in science. We deal with it in mathematics. What you're going to see with a parabola, however, is that there's always a low point or a high point, depending on whether that parabola opens up or down. These low points and high points are known as a vertex. The vertex is the highest or lowest point on a curve. So, tell you what, a little introduction right here. Let's get down to what kind of problems you're actually going to be dealing with. Take a look at our very first problem right here. This is a snapshot right from what we have for Alex. Letter A, does the parabola open upward or downward? What do you think? Downward. You could see these arrows would be pointing down. And then, of course, we're going to continue on. We're going to address, are there x-intercepts? Are there y-intercepts? Now, as you're looking right here, and I can make this just a little bit bigger, does this parabola ever cross the x-axis, which goes left to right? Does it ever intersect it? No. And it's perfectly okay to say that there are no x-intercepts. In fact, that's going to be one of the options that you're going to have. Here's a perfect example. The x-intercepts, there are none. You never cross the x-axis. Y-intercepts, however, you will always have one y-intercept. Does this parabola cross the y-axis? Yes. At what coordinate? At what number? -6. I heard someone say you're absolutely correct. So that's exactly where we're going. I'm going to pause the video just for a moment to set something up, to show you something on Alex. Okay, I've just opened up your homework 5.1, something you're going to be working on in just a moment. You're going to be given, guys, parabolas that can look very different. Here's my question to you. Does this parabola have x-intercepts? Yes. How many does it have, in fact? 2 of them. You can see that right here, as I'm running my pen, on a video, you might not notice that it's a 1. X equals 1. Where else? Also, -3. If you ever have that, guys, you'd have to answer with commas. You'd have to write like 1, -3 if that were the case, okay? Likewise, you could also have a parabola that just touches at one point. And I've drawn that in red right here. It's okay to just have one x-intercept. So for x-intercepts, guys, you might have one, you might have two, you might have none. And you just have to look at the problem and work from there. But once you do some of these, guys, you're going to go very, very, very quickly. Now, the vertex, I'm going to jump to D real quickly. The vertex is the highest or lowest point on the curve. What do you think this x comma y is on the screen? What do you think our vertex is? -2 comma -2. You're going to have to write that out as a point, right? It's an x value and a y value. You can see from the origin, we go 2 steps to the left, we go 2 steps down. The axis of symmetry is a line. It's not a number. It's a line. And guys, as you're looking at a vertical line, vertical lines always start with x equals. Guys, I hope you're taking good notes because you're going to get the benefit of using the notes when you take this on a test. And I'm going to put a little star here and say you must have x equals. Earlier this morning and the other day, so many kids were getting upset. They were saying, I keep getting this problem wrong. I'm convinced I know how to do it. It doesn't seem this bad. And the reason why they were getting it wrong is because they weren't writing the axis. They weren't writing the equation. You have to say x equals a number. Guess what number you're going to write? Always the x-coordinate of the vertex. Always the x-coordinate. So if I may, I'm going to scroll back up here real quickly. Let's just hypothetically say that a vertex was 4, 1. Guess what you'd have to write for your axis of symmetry? What would you have to write? X equals 4. Not 4, but x equals 4. Okay? When you take a look over here, you might have a point like 6, 3. Guess what your axis would be? X equals, what do you think? 6, right? So just remember, when you're writing an axis, guys, it's not just the number. You need the equation of a line, and you always got to have x equals. Okay, we doing okay? All right, so the next problems are actually review of multiplication of algebraic expressions. We're going to FOIL. And guys, when I say FOIL, this was an acronym. F stood for first. O stood for outside. I stood for inside. And I'm running out of space. L would be last. And sometimes kids look at that, they'll say, well, what do you mean, FOIL? I mean, look, it's as if you look at this X right here, and you're just distributing that X out in front to the X and the -4. That's your first multiplication and the outside. So what is X times X? What do you think? Not 2x, but x squared. X squared. X to the second power, right? And then what's x times a -4? We get -4x. So that's your first. That's your outside. But now it's as if I'm going to say, just worry about this +1 and distribute that with an inside and a last. So I'll say a +1 times x, that's a +1x. And a +1 times a -4 is a -4. You think we're done? No, we got to combine our like terms. What's a -4x added to a 1x? -3x, right? And there you go. You'll have x squared minus 3x minus 4. This is review. This is stuff that hopefully you're looking at and you're saying, I know how to do this. I've done it before. Look, let's do another one. You're going to FOIL. So take your 3c and multiply it to both. So we're going to go 3c times c, and that's going to be 3c squared. 3c times minus 6, help me out, what do we get? Minus 18c. Now do your inside. Negative 1 times c. Well, you get negative 1c. Then you take a negative 1 times a negative 6. Negative times a negative is a positive. And it's real tempting to say we're done, but you just have to put your like terms together. Negative 18c minus 1c becomes negative 19c plus a 6. All right, so guys, we are so close. We are so close to being done. We have one final problem, but please change it. Please change it. The problem that was originally written down is a little simpler than what Alex is really repeatedly writing out for kids. All I want you to do is put a plus 5 after that function. So we're going to rewrite negative 4, parentheses, x minus 3 quantity squared, and then we'll say plus 5. And we're almost through here. We just have to break this down, and then we're done. This plus 5 does complicate matters just a little bit. But guys, the order of operations, you know the order of operations. Please excuse my dear Aunt Sally and so forth. What do you always have to do first? You always have to do what is inside parentheses. Then what do you have to do? Exponents. Like, please excuse my dear Aunt Sally. Like, first you do parentheses, then you do exponents. You got to deal with exponents. You got to deal with that squaring. So, look, I'm going to break this down. I'm going to say squaring really means what? Multiply to itself. Multiply whatever you have to itself. Like if I asked you to find 3 squared, 3 to the second power is 9, right? It's 3 times 3. 5 squared, it's 5 times 5. So what's x minus 3 squared? Well, it's x minus 3 times x minus 3. And then you can think, well, what do I do now? You got to FOIL. It's what you were doing. That's the big, big, big common theme of the day. It's the number one repeated skill that shows up the most. Look at this. I'm going to distribute. I'll write my negative 4 out in front. X times x here, you get x squared. X times a minus 3, I'm going to get a minus 3x. Then I'm going to do my inside, and then my last. So negative 3 times x, I'll get negative 3x. Negative 3 times a negative 3 is a plus 9. We're getting closer by the moment. Here's the thing. Sooner or later, you're going to have to combine like terms. Why not combine them when they're easier and smaller? That's a very good rule of thumb. If you can combine like terms earlier, do that. Negative 3x and a negative 3x add up to minus 6x. Okay, a negative 3 and a negative 3. Look, the brackets, the little inside there, it got a little bit easier, a little bit nicer, simpler. What do you think I'm going to do with that negative 4 now? Multiply it. You got it. Negative 4 times x squared, I get negative 4x squared. Negative 4 times a negative 6 is a plus 24x. Negative 4 times 9 is a negative 36. Don't multiply negative 4 to 5. That's not part of the parentheses. And now one last thing. You got to combine your like terms. What do you think you get? Negative 36 plus 5. What's that? Negative 31, right? So your homework is going to be 5.1.